Hi, my name is Manish Gupta, and in this video, I'm going to talk about prompt engineering. So let's get started. What is this pre-train, prompt, and predict paradigm? Well, if you think about it, the way deep learning for NLP has progressed, there are these four interesting paradigms. Fully supervised learning in a non-neural network manner, which is what I also like to call as traditional machine learning. Here, the primary thing was to engineer features, come up with better features like part of speech tags or sentence length and so on, and therefore improve your classification accuracy. Right? Then came in neural network based fully supervised learning, where the idea is to engineer architectures, try to figure out what architecture is most suitable for my task. And then starting with BERT and GPT and so on, there came in pre-training and fine-tuning as a paradigm where the idea was to engineer for objective functions like mass language modeling and next sentence prediction for BERT, or autoregressive modeling for GPT, or or translation language modeling for XLM and so on. Right? And now what is really popular is pre-train, prompt, and predict. Right? Um, where the idea is to engineer the right prompt. And prompting is not just new in terms of ChatGPT. Well, prompting has been around for quite some time. In fact, one of the first papers to bring in prompting was T5, where they basically said that, hey, I'll express every NLP task as a generative task. And a single model should be able to perform all different tasks if supplied by the appropriate prompt. Yeah. So this is how we have moved from fully supervised learning to pre-train fine-tune to pre-train find prompt and predict. Clearly, fully supervised learning needs large task-specific label data, and that's not easily available. Pre-training reduces the need for this task-specific label data by making the model pre-train and learn enough English or enough of the basic language, and then you can actually fine-tune with small amount of label data. Now, prompting actually attempts to eliminate the need for label data completely. Yeah. Uh, so how does prompting work? Well, the idea is that you have a single pre-trained language model and it can do multiple tasks depending on the prompt. So your prompt could be I missed the bus today. I felt so what, right? And then the language model can fill the blank with an emotion bearing word. So it could do text generation, right? Or the prompt could be designed in this format: English colon I missed the bus today, French colon what, and then the language model sort of understands that we are expecting it to come up with a French translation. So that's the way you can use pre-trained models with prompts. So now the question is, what is prompt engineering? Well, it is the approach of finding the most appropriate prompt to allow a language model to solve the task at hand. So how can I design the task instructions or tell the language model appropriately so as to do the task that I want to be done? So how does prompting work? So let's look at an example from a sentiment analysis perspective. And let's consider a five-class classification problem, sentiment analysis five-class problem, where ratings, for ratings 1 to 5, where 5 is awesome and 1 is the worst. Right? Let's say there is an original review X. I love this movie. Okay. So if you want to tell the language model, hey, do sentiment analysis, the way you would do that is to first use a prompt template. Um, you would basically use a prompt template of this kind, which has X and Z placeholders, where X stands for the input and Z stands for expected output. Okay? For example, X overall, it was a Z movie. Now, for this particular case, what you would do is consider this I love this movie as X, and therefore the prompt template, when applied to this input, would look like this. I love this movie. Overall, it was a Z movie. Now notice that the template words may not be natural language tokens only, like overall, was, movie, and so on. They could actually be virtual words also, represented by some numeric IDs and embeddings and so on. In fact, in this prompt template, there is only one X and only one Z. Well, you could have a different number of X and different number of Z slots depending on the task. For example, for natural language inference, you would have two different X slots, one for premise, one for hypothesis. Okay. Also, so basically, once you have decided the prompt template, you essentially have the first step as prompt addition step, second step as answer search step, and third step as answer mapping step. Okay. So the prompt addition step, you essentially apply the prompt template to the input, which is this: I love this movie. Overall, it was a Z movie. Now Z could be in the middle of the prompt, like here. It is not at the end, the middle of the prompt, right? And then it is called the close prompt. or it could be at the end of the prompt, like in ChatGPT kind of scenarios, and in that case, it is called as the prefix prompt. Okay. So that's that. Now, you also decide for the task a set of permissible values. So, for example, since this is a sentiment analysis task, these could be a set of permissible values that you expect the model to output. So overall, it was what kind of a movie? Well, excellent movie, good movie, or okay movie, bad movie, and so on. Okay. So once you have this set of permissible values, the task of the language model is to do answer search, which is basically searching for the best Z hat from this set of Z that maximize the LM score. The language model basically tells you which of those Z hat from the set of Z is the best. Now, finally, after you have these things, let's say the model selects overall, it was a fabulous movie, right? Now you want to figure out fabulous means what? 1, 2, 3, 4, 5, because your output has to be from 1 to 5. Okay. So therefore, you need answer mapping, which is basically mapping the highest scoring Z hat to the highest scoring Y hat, which is the output you desire, okay, class label that you desire. So, if the task is basically, let's say, just language generation, or like translation or autocomplete and so on, you can just use identity mapping here. You could just say my Z hat is my Y hat. Right? But if the task is more of an NLU kind, natural language understanding, you typically have a fixed set of classes to which you want to map one of the Z hats to. Right? So for example, excellent, fabulous, wonderful could all map to rating 5. So this is how prompting works. Yeah. So here are some examples of prompt templates for popular tasks. Like for example, sentiment analysis. Let's say we just looked at this. I love this movie. So X, the movie Z. Topic identification. So he prompted the LM. And the text is about what topic, right? So and you could have answers as sports or science. Intention kind of a classification problem. These are all text classification problems, right? What is the taxi fare to Denver? The question is about what intent, quantity, city, and so on. There could be other kinds like NLI, so which is text pairs classification, so X1 and X2, and then the template could be just this, an old man with whatever, that's the hypothesis, question mark, so you have to fill here yes or no for the second sentence. Yeah. Uh, Similarly, there could be a summarization task, and you could denote that by a prompt like TLDR or a translation task, and you could basically give the language names with colons as to indicate that you're trying to do translation task. Okay. Now, there's several design considerations for prompting. Mainly these four. Pre-trained LM choice, right? So, which language model do you want to use? Now, that depends on whether you want to have an LU task or an LG task. So, typically for NLG task, prefix-based prompts are more suitable, and therefore, these kinds of language models, which are typically dependent on transformer decoder or transformer encoder decoder, are more suitable. So transformer decoder based models include GPT, GPT-2, GPT-3, GPT-4, ChatGPT, right? While encoder decoder language models include T5, MAS, and BART for English, right? If you want to do NLU tasks, then closed kind of prompts are more suitable, and therefore the language models like BERT and Roberta are more suitable. The other choice that you have to make is about doing prompt engineering. So how do you create the prompt and assign and use the right prompt template? Right? So you could basically do manual prompt engineering or automated prompts. Manual prompt, there are some data sets also available like P3, which give you which are manually generated prompts. And the interesting part about manual prompt engineering is that yes, it's an art and it takes time and experience. So it's sort of difficult because time consuming. It's manually done, right? Now, automated prompts, you can also create prompts automatically, and we'll discuss that in the next few slides. Um, but those prompts can be static or dynamic. Now, static prompt means that you have a prompt per task and doesn't vary for different inputs. The template, it remains the same, whatever be your X, your input X. Okay. But dynamic prompts basically mean that they're custom for every input. So that's that. Similarly, automated prompts could be discrete or continuous. Discrete prompts basically mean that they are human readable, meaning they have natural language words in them, while continuous prompts basically mean that they are embeddings and they are not human readable in that senses. They are numeric IDs in that senses. Yeah. Um, uh, Now, the third consideration is answer engineering. So, which basically means designing Z of all permissible values for your classification task, and also designing the mapping function from Z hat to Y hat. Lastly, what is important while doing prompting is training strategies. So in some cases, in most cases, of course, you will have language model parameters, which you may need to tune while doing fine tuning. Uh, while in some cases, you'll also have specific parameters for prompts, specifically cases where you have continuous prompts, right? And in that case, you may want to either tune those parameters or keep them fixed while you're doing fine tuning. So let's discuss these aspects one by one in this video, right? So let's talk about automated prompt template learning. Um, so automated prompt templates could be discrete or continuous. Discrete prompts basically mean hard prompts. They are natural language words. Continuous prompts mean soft prompts. They are essentially embeddings, right? So they're not human readable. They're not natural language words. Okay. So discrete prompts, how do you create them, right? So 5 interesting ways of creating discrete prompts. Prompt mining, prompt paraphrasing, gradient-based search, prompt generation, or prompt scoring. Yeah. So let's say if I want to come up with some prompt for a particular task where the input is X and the output is Y. So I can basically go ahead to Wikipedia and try to scrape a large text corpus. It could be Wikipedia, it could be some other corpus, and look up for strings X and Y. So whatever sentences contain the strings X and Y, I'll basically try to find the middle words or dependency paths between inputs and outputs. And they help me define the prompt appropriately. Okay. Um, the second one is prompt paraphrasing. So let's say manually, if I created some hard prompt, or I actually used prompt mining to create such a prompt, let's call it as a seed prompt. I can actually paraphrase that prompt and then try to see if it gives me better accuracy on my validation data. Right? Now, paraphrasing can be done using several ways. For example, round trip translation, phrase replacement using some thesaurus, or neural rewriter. So use some neural paraphrasing tools so as to rewrite. The third method is gradient-based search. So here you search for prompt tokens that can trigger the underlying pre-trained language model to generate the desired target prediction. So it's more like, you have some prompt tokens and you randomly initialize them, and then you want the language model to be able to update them such that your overall accuracy of the downstream task improves. Okay, so that's that. Prompt generation. So prompt generation is about using language models themselves to actually come up with prompts. For example, how about asking ChatGPT, hey, what is a good prompt to do summarization? Yeah. So that's that. So, or you could actually use T5 model to generate template tokens by specifying the position to insert template tokens within a template. Okay. You could also use T5 model to generate unique domain relevant words for each input. So maybe you have some inputs and then you have certain domain, let's say a query, and you want to figure out whether it is a hateful query or not. But then you also have some domain classification of queries. So then you could actually also bring in some keywords using T5 model and then include them in the prompt so as to have an input specific prompt. Okay. Lastly, prompt scoring. So if you have several candidate prompts coming from any of these methods, then you can actually select the best prompt, which could be individual input specific, such that the prompt has highest language modeling probability. So those are all automated ways of coming up with hard prompts or discrete prompts. For continuous prompts, well, there are some interesting methods. Okay? The most popular method is called prefix tuning. So in this method, you prepend a sequence of continuous task-specific vectors to the input. So for example, you can choose how many vectors, how many different vectors do you want to bring in per task. Let's say if you have like 8 tasks to be done, you can bring in, yeah, or maybe 3 tasks to be done. Maybe you can bring in, or other 8 tasks to be done. Yeah, maybe you can bring in log 8, which is basically 3 different task-specific vectors. And then you can actually tell prefix tuning model to essentially keep so while fine tuning on a few short data, you can actually tune only the task specific prompt parameters, while you can keep the language modeling parameters frozen, right? So that's basically prefix tuning. uh, Remember, this will lead to vectors which are not interpretable. So they will not be natural language words anymore. There will just be some vectors which sort of represent the task that you're trying to get done. Okay. You could also by initializing using discrete prompts. So you could initialize virtual tokens based on some discrete search method, any of these methods, and then you can fine tune it as you're doing tuning. And the last one is hard soft prompt hybrid tuning. So you could basically have some input prompt template of which some of those words are hard, they are basically fixed, while others are tunable. So you could insert some tunable embeddings into a hard prompt template. One of those methods is p-tuning, prompt tuning, right? In that sense, as it is called. So those were some of the prompt engineering methods, methods for prompt template learning. Well, for classification tasks, you need to also care about answer engineering. And in that case, in general, your answers could be any of these three types. They could be sentences. So for natural language generation, they could just be sentences and phrases and so on. So there you don't need to do much answer engineering because hey, whatever output comes from the language model is your answer. You can directly put it out as an answer. So you can use it for with prefix prompts and use it for NLG tasks, which is great. But if you're doing NLU tasks, you have to either do tokens as predictions or spans as predictions. So as tokens as predictions, one of the tokens in the pre-trained language model's vocabulary or a subset of vocabulary could be output as an answer. And in span, this is typically used with close prompts. In span, for example, for question answering, you could say that, hey, given this passage, given this question as input, well, my answer is starts from this word to that word and ends at that word, right? So that's basically span detection. And here the answer is basically a span. Yeah. So for sentence kind of answers, as I mentioned, there's no answer engineering required, but for the others, for tokens or spans and answers, you need to do answer engineering. Now you could do that either manually or automatically. When you're doing manual answer space design, you have to think whether it is unconstrained space or constrained spaces. So again, for sentence, for NLG kind of task, it is basically unconstrained typically. But for NLU kind of task, it is typically constrained space. So it's needed for tasks with a limited label space, such as text classification or entity recognition, or multiple choice question answering. Right? And then you have to manually design possible answer lists for every class label, like we did for sentiment analysis, right? So for sentiment analysis, for example, we can say that, hey, excellent, fabulous, and wonderful are the answer lists for class 5. In case of automated answer space design, the idea is that, well, you have some sort of an NLU task and you have answers coming in from this natural language generation model. You want to learn that mapping automatically. Yeah. So for which you basically need answer paraphrasing. So you start with an initial answer space Z dash, right? Like we did for sentiment analysis, and then you use paraphrasing so as to expand its coverage. Yeah. And then finally, when natural language generation model generates some output, the probability of the final output class is defined as the marginal probability over all of the answers in that paraphrase set, right? So basically saying, yes, if fabulous or excellent or wonderful all map to 5, then any of them being so the overall probability for 5 would be probability of the language model generating excellent, generating fabulous, generating wonderful. Yeah. You could also do automated answer space design by label decomposition. So for example, and this is applicable where the class label actually has multiple tokens in it. So for example, if the class label is like that, per colon city of death, you can decompose it into 3 words, person, city, and death. And then your probability of answer span will be calculated as sum of each token's probabilities. Well, when talking about prompt engineering and using prompts, multi-prompt learning is immediate. Yeah. So there are 4 ways of doing multi-prompt learning, 2 of which we'll discuss on this slide and 2 on the next slide. So here are these 4 ways: prompt ensembling, prompt augmentation, prompt composition, and prompt decomposition. Okay. What is prompt ensembling? Okay. So let's say if you want to basically take the country China and you want to ask what is the capital of China. So you could ask it in several ways. China's capital is Mask. Mask is the capital of China. Capital of China is Mask. Okay. So prompt ensembling is basically using multiple prompts for an input to make predictions. And then these multiple prompts could be discrete, could be continuous. In this case, they are all discrete. But well, you could have a mix as well. And then when you get the predictions from all 3, you could do either uniform averaging or majority voting, or you could do weighted averaging. So if you believe that certain prompt template typically gives you better results, or you have sort of optimized the weights, using gradient search itself, then those are the weights you can use to combine the results coming out from multiple prompts. You could, in fact, also design an interesting prompt where you can actually ask the model to behave like five experts and therefore come up with five different answers. So that's another way of doing prompt ensembling using a single prompt. Another way of doing multi-prompt learning is prompt augmentation or demonstration learning. So, for example, if I want to ask this question, add up two numbers 6, 8, I could express it as a single prompt 6 plus 8 equal to mask. But a better idea is to actually give this entire thing as prompt, where I give two examples that hey, 1 plus 1 is 2, 2 plus 5. Oh well, there's a mistake here. 2 plus 5 is 7. 6 plus 8 is what? Okay. So by giving two examples, I'm actually helping the model understand what is the kind of task that I'm expecting it to do, and also second, I'm helping it understand that this is the format in which you should give me the answer. Okay. So prompt augmentation is the idea of providing a few examples or demonstrations. There are two issues here to consider, like sample selection. So basically, what examples should I provide? So, we can use sentence embeddings to sample examples that are close to the input in this embedding space. Okay. We can actually also provide positive as well as negative examples to help the model understand what things to avoid or what things to focus on. Okay. The another thing that you have to consider is sample ordering. So which order you should provide. Now, in general, curriculum ordering is good. Easier ones first, harder ones later. However, you can also learn, what is a good permutation of examples that you would want to provide. Some people have also observed that learning a good separator between these examples also leads to better accuracies. The other two methods of multi-prompt learning are prompt composition and prompt decomposition. So prompt composition method is as follows. Let's say you have a complex composable task. You can use multiple subprompts, each for one subtask, and then define a composite prompt based on those subprompts. So let me give you an example. So let's say we want to figure out um, Google became a subsidiary of Alphabet. So relation extraction, right? We want to figure out the relation. So here, subtasks include identifying the characteristics of entities and classifying the relationships between entities, right? So therefore, typical subprompts could be the dash Google, so the company Google, or the company Alphabet, and then Google became a subsidiary of, right, Alphabet. So the idea is that given these three subtasks that we have in mind, a good prompt would look like this: the mask Google, mask the mask Alphabet, right? So that's basically called as prompt composition problem, where you want to do, you want to do two different problems: entity identification as well as relationship identification, and you express both of them in the single prompt. Okay. The other way around problem is called prompt decomposition. In some cases, prompt decomposition helps. For example, if I want to, let's say, get NER task done here, Mike went to New York yesterday, asking the model to actually come up with the prompt types with entity types in the same prompt may not be very accurate. So breaking down the holistic prompt into different sub prompts may be a good idea, and then answer each sub prompt separately. So maybe we can actually ask in one go, hey, here is the input. Mike went to New York yesterday, and Mike is mask entity type. So tell me what entity type. And then another sub prompt, we can actually ask for New York's entity type. Okay. So that's about multi-prompt learning. Now, next we'll talk about what are popular training strategies for prompting methods. Okay. These strategies actually vary on two different axes, whether the parameters of the underlying language model are tuned or not, while you are doing few short learning. Okay. So remember, you have a pre-trained model, and maybe the pre-trained model was trained with prompts, and you want to do fine tuning or few short learning for a particular downstream task. Okay. So when you're trying to do that, you could have these two choices: whether the parameters of the underlying LM model are tuned or not, and whether there are additional prompt-related parameters. Accordingly, there are five different strategies as you see them here. Yeah. Prompt-less fine-tuning, which is basically no prompts involved. Okay, no prompts involved in pre-training, no prompts involved in fine-tuning. There are only language model parameters to be tuned. And well, the examples are BERT or BART. They don't believe in prompts anyway, right? So the good part is that this method is simple, no prompt design involved. However, language models may overfit. In fact, fine-tuning has been known to actually cause catastrophic forgetting. The model just forgets whatever it was pre-trained, all the knowledge that it gained while pre-training. Um, Now, the other four methods, of course, include prompts. The tuning free prompting is basically you have frozen language model parameters and you do not have any prompt specific parameters. Okay? For example, what is popular now? GPT-3 or ChatGPT or GPT-4 and so on, right? So here the interesting idea is that to make it work, you can actually do prompt augmentation by doing in-context learning or adding a few examples to explain the model. Hey, this is the way you can actually get the output. So explain the task using 2 examples, 3 examples, something like that, and then it just works really nicely. Okay. This is efficient because there are no parameter updates involved, so no training steps really involved. No catastrophic forgetting can happen because you're not updating the parameters anyway. It's applicable in zero-shot settings. No examples. I mean, zero-shot in the sense, yeah, you need 2 or 3 examples for prompt augmentation. Otherwise, you don't need much. However, since everything depends on the prompt, heavy prompt engineering is needed. So providing more examples in the prompt can be slow at test time. So those are some of the disadvantages. For fixed language model prompt tuning, the idea is that the language model is fixed, frozen, but there are tunable, tunable prompt parameters. A popular method is prefix tuning. Yeah. So here the idea is that the good part is that it can retain knowledge in language models because they are frozen, so no catastrophic forgetting happens, and is suitable in few short scenarios. Yeah. However, it is not applicable in zero shot because you still need to learn these prompt specific parameters. Prompts are usually not human interpretable and difficult to manipulate. Prefix tuning kind of methods learn continuous prompts and they are not human interpretable. The fourth one is fixed prompt language model tuning, where the idea is you tune the language model parameters, but you essentially don't have any prompt-based parameters. Yeah. So this is typical. This is the typical idea in general that hey, this is the typical supervised learning way of thinking, right? Hey, you have pre-training done, and then but you did pre-training with prompts, and then you have a new task. So well, you fine tune for that particular task the language model, but you don't have any prompt-specific parameters. Okay. So it is typically better than this method, fixed language model, because well, you can actually tune the language model here. However, prompt or answer engineering are still required, right? So it's not applicable in zero-shot scenarios, clear. The last one is the most expressive method, prompt plus LM tuning, where you tune the language model parameters. You also have prompt specific parameters which you tune. Okay. But then it has its own drawbacks as well. It requires training and storing all parameters of models. Prompts are usually, again, not human interpretable or manipulatable. Yeah. So those are issues. Yeah. Okay. Here are some example prompts for popular tasks. So let's say for fact probing. So the prompt could be Adolf Adam died in Z and iPod Touch is produced by whom. So, well, the output answer set is the entire vocabulary in these cases. Text classification. So which of these choices best describes the following document? And you can have class A, class B, class C as part of the prompt. And then you have X, comma Z, X and Z. So essentially X is the document and Z is to be filled. This is also very useful for various kinds of classification tasks where you want to describe the class categories also as part of the prompt. Right? For example, you could have other things like how is the text best described, whether it is science, sports, or fiction, or whatever, right? And then you can give the text and then ask the model to come up with Z, the output. And the answer, of course, has to be ABC only. Answer has to be ABC. Natural language inferencing task. This is a prompt that we saw earlier in the video. Common sense reasoning task. The trophy doesn't fit into the brown suitcase because that is too large, and the possible answers could be trophy or suitcase, one of the nouns that was already there in the prompt. Yeah, and so on. So, for example, there could be other question answering tasks. So, prompt could be question, passage, and Z, where or it could be passage. According to the passage, answer this question, and then come up with the answer. Yeah. Uh, so these are more like span kind of answers which are expected, answers which are spans from the given passage. Machine translation prompts, summarization prompts. So these are some popular prompts for popular tasks. There is also a nice prompt data set called as P3. So feel free to look up P3. There's a GitHub repo for P3 prompts. Recently, people have started also doing something called as chain of thought prompting. So the usual prompting works as follows. You basically give the task description, you give, let's say, a question, and then you can give options, so multiple choice question answering. right? And then you give an answer. So it's an example, right? So it's an example to tell the model, hey, this is how you should solve the problem, right? And then you give your own question and you give the options and you expect the model to produce the answer. And notice that you can give A colon, Q colon as extra hints for it to understand the pattern. Now, in general, this kind of stuff has been shown to not come up with very good answers. But then what has been shown to improve on these is what is called as chain of thought problem, where you still have the task description, question, options, and answer, but then answer is descriptive in nature. It's like thinking step by step. So producing the chain of thought, chain of logical reasoning, why the answer is D. And people have typically observed, and then of course you give your own question with options and ask it to think step by step. And then people have typically observed that yes, not just provides you detailed answer, but also provides you typically right answers, more correct answers. Okay, here are some, a mix of tips for good prompt design, especially for GPT, ChatGPT kind of models. These models are known to parse prompts in English and Spanish better. So even though you might think that Chinese prompts could be shorter, but they typically work nicely with English or Spanish prompts. You can use prompts nicely to control text, to control the language, tone, persona, or length of the generated text. In general, in fact, you can think of prompt engineering also as controlled text generation. There are many similarities, right? Um, Multitask outputs is a good idea. So just like chain of thought prompting, asking it to generate two things, one, the answer and the reasoning is a good idea. Similarly, asking the model to do more things like generating explanations or related outputs is a better idea. So not just that it gives you better results, but also it saves you cost if all tasks had to be done anyway, right? So if you have like three tasks to be done on the same input, you would rather put them together in the same prompt and ask the model to do them together. Typically, your task definition should be clear, simple, unambiguous, and exhaustive, as if you are sort of giving the task to an attentive judge, to a very attentive person. Okay? Recency bias. So these models have tend to basically give more importance to more latest part of the prompt, and therefore repeating the most important instructions at the end of the prompt would help. Choice of examples. Examples should help constrain the output format. You should choose examples such that they are very clear and help the model understand the task better. So you could also use examples to exactly constrain the output format. So if you're expecting, the model to answer 2 plus 3 is equal to, let's say, 5 in words, FIVE, then you would also give more examples like 1 plus 2 equal to 3 and so on, so that the model understands this is the format which you expect the answer. Yeah. Cost. OpenAI and in general, if you are using these models on your own machines, right, the computation cost increases with the length of the input plus output. And therefore, it is a good idea to have shorter prompts. Now, of course, on one hand, we want prompts to have a lot of context in them. On the other hand, we want shorter prompts. But the two, there is a good trade-off, and one has to explore that trade-off for their particular downstream task. It's good to have short prompts, and it's also good to have to explicitly add phrases to force the model to generate shorter outputs, because the longer the outputs it generates, the more compute power it uses. Yeah. Avoid redundant context. So typically these models like GPT, ChatGPT, and so on, they have essentially learned the content, the body part of the URL. And therefore, if you think that, hey, you can give some the entire document body as part of the prompt context, right? It may not help you much, but it will increase the size of the prompt by a significant amount. So therefore, whenever you're designing prompts, be careful about how much value add does it do to improving accuracy of your downstream task versus the cost it adds in terms of number of tokens. In summary, in this video, I talked about prompt engineering, which is finding the most appropriate prompt to to allow a language model to solve the task at hand. We talked about several automated prompt template learning methods, both for discrete prompts as well as continuous prompts. We also talked about several methods for multi-prompt learning, prompt ensembling, prompt augmentation, prompt composition, and prompt decomposition. We also talked about multiple popular training strategies for prompting methods, which differ in terms of whether language model parameters are tuned or prompt parameters are specifically tuned when you are doing few shot learning. We also talked about a few tips for good prompt design for GPT, ChatGPT models. Hope you liked the video. Thank you for watching. Please connect with me on my LinkedIn and look at my research on my homepage. Thank you.